Okay, folks, we're going to talk a little bit about solving systems, not so much algebraically, but we're actually going to be talking more about how to graph these and solve, similar to what we've done before in the previous section. So let's take a look again at the idea of graphing these to solve these systems. On the ACT, they may ask you to go ahead and solve this system algebraically or elimination or substitution. But it's the ACT and it doesn't matter. All you need is the correct answer. And at times, the quickest way to get the correct answer is by graphing this. Set both these equal to y. Let's do the first one. 3x minus 4y. Sorry, plus 4y equals 12. Again, solve for y, subtract 3x. And then divide everything by 4. Second one, subtract 2x from both sides. And then that one is actually already done. So now let's go ahead and graph this one and this one, and we'll take a look at what that screen looks like. Ta-da! After modern technology has helped us look at this graph, we put both these into the Y screen, see where they intersected, and it's at 5.6 and negative 1.2. That's all nice and easy and dandy, but there are some special cases that come up now and then when actually solving these by graphing and actually using this technique to solve real-world problems. Oh no, I don't want to save the image, but I do want to move on. Here's another one that we can actually do, and we could probably use substitution right here. Let's just go ahead and solve for x right here. Whoops, too many equal signs. And since this is the same thing as x, I can plug all of this into this x right here. So here's what that would look like. Pardon me, screen function here. There we go. Here's what that would look like. You are going to take negative 2 times x minus 4y equals negative 5. Distribute. Combine. Simplify. And y is going to equal 5 halves. Now what you would do is go ahead and plug this back into the original equation for y. X plus 3 times 5 halves equals 5. And to simplify this, we're going to have x equals, multiply straight across for your fractions, 15 halves, multiply straight across, 15 halves, equals 5. And then subtract 15 halves from both sides. Well, if you think about this, this is really 7.5. So you're really going to be subtracting 7.5 from both sides, if you convert that to decimal. And you're going to have negative 2.5. And this could actually be called positive 2.5. So there's other ways of, instead of graphing, you can use to go ahead and solve these systems. If it's nice and easy and quick to go ahead and use substitution, then use substitution. But if you think it's going to take a little bit longer and you don't want to make mistakes, then feel free to go ahead and use the graphing calculator. So let's move on here. Let's talk about a real-world situation. I'm not really sure how real-world, but you can use anything from 6 piano lessons, 12 piano lessons to anywhere from, I don't know, getting some other type of lessons or buying bananas, oranges, what have you. This is pretty universal setup with these systems of equations. So a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music, books, CDs, software, are shown in the advertisement. Well, here's the advertisement. It says you can get 6 lessons for $300 and 12 lessons for $480. What is the cost of each lesson and the one-time fee for materials? Well, let's just take the first one right here. It says 6 lessons, so let's just do 6x for lessons. That includes a one-time fee for materials, so we're going to add the fee, let's just call that, I don't know, y, is going to equal $300. Again, 6 lessons, plus one-time fee equals $300. Another scenario they have for us is 12 lessons, so I'm probably going to write 12x plus the same one-time fee of y is going to equal 480. Well, if you simply solve for y on both these, and solve for y here, plug both these into your calculator and use second calc intersect and find the intersection, just like I'm going to do here. Ta-da! Now, the question you have in your brain cell is, how did he get that picture? I'm going to give you a suggestion of zooming out and then zooming out again, and then you might have to zoom out even further. Then do second calc intersect and find your intersection points. So we have 30 and 120, and we're going to write that down, 30 and 120 for y and for x. So this tells you that each lesson is $30 each, and this is a one-time fee. Hopefully that's clear as mud. Now let's take a look at a couple special situations. I'll even put special on here. Special and special. Good. Now, let's take a look at this one right here. Solve for y. And solve for y here. Oops. This one's a little bit more tricky. Let me go ahead and move this top one here. This one was real easy right here. This one, watch your negatives, ladies and gentlemen. We're going to subtract 3x from both sides. That's still going to leave me the negative y over here. We're solving for positive y, so we're going to divide everything by -1. And we're going to have our two equations right here. Whoops. Let's just drag that little piece right here. That one. It's still not grabbing it. I love that one. Oh, it's going to love that whole thing. Well, then let's just move this one. So we've got these two equations to graph. Do you notice anything about these two equations? Ah, yes, they're going to be the same line. I wonder what that's going to look like on the graphing calculator. Ta-da! You were right, it's the same line. This line right here is 3x minus 5, and this one right here is also 3x minus 5. Isn't that hilarious? Now, with this in mind, I want you to think about this. If it's the same line, what are our solutions? Well, how many times will a line intersect with another line when they're right on top? You're going to have infinitely many solutions. Let's take a look at the next one. Let's solve for y here. I'm going to go ahead and try and sneak this in here. This first one, 4x minus 6y equals 6. Subtract 4x. Divide by negative 6. And I'm going to do some simplifying here. 4 divided by 6 is going to be 2/3. Negative divided by negative is positive 2/3. And then negative 6 divides into positive 6 one time. The other one here, I'm going to solve for, I'm going to scooch up over here, negative 4x plus 6y equals 10. Add 4y. Then divide by 6. This here is going to have 2/3 x again. And then 10 divided by 6, otherwise known as 5/3. So if you look at these two equations, this one right here and this one right here, what can you tell me about the slopes? Ah, yes, they are the same, yet different y-intercepts. I wonder what that's going to look like. Ta-da! There you have it. As you guessed, it was going to be the same slope, different y-intercepts, so that means that they're going to be parallel. By the way, how many times do these lines cross? The answer is none. So if they don't cross, then that's right, there is no solution. Clever how that works out. Why don't you guys try these two on your own as I study these. Try these two and see what they look like when you graph them on your calculator. All right, ladies and gentlemen, if you have other questions about this, come in and see us, and we'll talk to you guys tomorrow.